Hello students, welcome back to my channel. It's my classes. Today I am going to discuss about the straight line. So first of all, we have to discuss about the direction cosines and direction ratios because it is one of the most important part of straight line. First of all, we draw a coordinate plane x, y and z. Let P be a point on this plane and OP be a line. Consider that OP makes angles alpha, beta and gamma with the coordinate axis. Then the cosine of these angles are called the direction cosines. Now we can find the relations between these direction cosines. To find the relation between these direction cosines, PM is drawn perpendicular to the x-axis. From the figure, we have cos alpha equals to OM by OP. OM by OP. Where OM equals to x. Therefore, cos alpha equals to x by OP. Similarly, we get that cos beta equals to y by OP and cos gamma equals to z by OP. Here the coordinate of O is 0, 0, 0 and the coordinate of P is xyz. Therefore, by distance formula, we get OP equals to root over x square plus y square plus z square. When we evaluate it, we get that cos square alpha plus cos square beta plus cos square gamma equals to 1. Now we can find the relation between the direction cosine and direction ratio. If ABC are the direction ratio of a line, the direction ratios of a line then the direction cosines of these lines are plus minus a by root over a square plus b square plus c square plus minus b by root over a square plus b square plus c square and plus minus c by root over a square plus b square plus c square. We can find the equation of a straight line in two forms. One is symmetric and other is unsymmetric form. If a line passes through a point x1, y1, z1 and have direction ratios L, M, N, then the equation of the line be x minus x1 divided by L equals to y minus y1 divided by M equals to z minus z1 divided by N, which is the equation of a line in symmetric form. The unsymmetric form of a line is the line which formed by intersecting two planes. Therefore, unsymmetric form of a straight line is a1x plus b1y plus c1z plus d1 equals to 0 and a2x plus b2y plus c2z plus d2 equals to 0, where both are planes. Now we are going to convert the equation of a line from unsymmetrical form to symmetrical form. So we first consider two planes a1x plus b1y plus c1z plus d1 equals to 0 and a2x plus b2y plus c2z plus d2 equals to 0, which is the equation of the plane. Since the line lies on both the planes, therefore it must be perpendicular to the normal to the planes. If we consider LMN be the direction cosine of the line, then by the condition of perpendicularity, we get L into A1 plus M into B1 plus N into C1 equals to 0 and L into A2 plus M into B2 plus N into C2 equals to 0. Since A1, B1, C1 and A2, B2, C2 are the direction ratios of the plane. By cross multiplication, we get the value of direction ratios of the line, that is b1 c2 minus b2 c1, c1 a2 minus c2 a1, and a1 b2 minus a2 b1. If we consider that the line meets the plane z is equal to 0, then the z coordinate is 0. Let the point is x dash y dash 0. Therefore, clearly this point satisfied both the equation of the planes. And we get that a1 x dash plus b1 y dash plus d1 equals to 0 and a2 x dash plus b2 y dash plus d2 equals to 0. By cross multiplication, we get the value of x dash and y dash, that is x dash equals to b1 d2 minus b2 d1 divided by a1 b2 minus a2 b1, and y dash equals to d1 a2 minus d2 a1 and a1 b2 minus a2 b1. Therefore, the line passes through this point b1 d2 minus b2 d1 divided by a1 b2 minus a2 b1, comma d1 a2 minus d2 a1 a divided by a1 b2 minus a2 b1, comma 0. Since we get the point through which the line passes and the direction ratio of the line, therefore we get the equation of the line in symmetric form. Using this procedure, we can find the equation of a line in symmetric form. So we can do an example. First of all, the given equation of the planes are 8x plus 12y minus 13z minus 32 equals to 0 and 4x plus 4y minus 5z minus 12 equals to 0. Similarly, we can consider that LMN be the direction cosines of the line, and clearly the line lies on both the planes. Therefore, the line is perpendicular to the normal to the planes. By the condition of perpendicularity, we get 8L plus 12m minus 13n equals to 0 and 4m plus 4m minus 5n equals to 0. By cross multiplication, we get the value of direction ratio, and that is 2, 3 and 4. Now we consider that the line touches the plane z is equal to 0 at x dash y dash comma 0. Therefore, clearly it satisfies the equation of the plane. Therefore, the equation becomes 8x dash plus 12y dash minus 32 equals to 0 and 4x dash plus 4y dash minus 12 equals to 0. Again, by cross multiplication, we get the value of x dash and y dash. Therefore, the equation of the line pass through the point 1, 2, 0, which have direction ratios 2, 3, 4. Therefore, the equation of the line becomes x minus 1 by 2 equals to y minus 2 by 3 equals to z by 4. Thank you.